Hello and good morning or afternoon. My name is Jason Knight and I am a member of Group 7. Today we are going to be covering our library and management system. This is for CPSC 3703, Software Modeling and Design. For our final presentation, group members are Jonathan Bell, Acacia Fernandez, Jason Knight, and Pedro Velasquez. Here we have a brief overview of what we'll be covering today. First, we'll look at client overview, move on to project scope, and look at design criteria and functional constraints. And then we'll move on to modeling evolution. We'll look at the use case model, the system context class model, the static model, and finally, the dynamic model. Our client for this project was a local public library who wanted to create a client server system where customers could interact with the library. The actors themselves are the users or the customers, and the library employees who kind of administer and manage the system. Okay, so now we're going to look at the design criteria. So the client server requirements passed down to us by the library. They wanted an inventory database of all books. They wanted an accounting system with user and employee accounts. They need notifications sent out, upcoming due dates, and then overdue books. And then they wanted users to be able to pay for the late fees online or actually check out and get books shipped to them from the library online. So users obviously need to be able to interact with database. It needs to be searchable through Boolean searches, advanced, searches, regex, to be able to search by author, ISBN, what have you. They need to be able to edit their own user accounts, and they also need to be able to access the pay system. And then from an employee's perspective, they need to be able to add or remove books from the database. They need to be able to edit the books currently there, and then also all administrative functions with user accounts. Now, all of this is done with physical technology that's located at the user's home, and then also within the library itself. As far as actors limitations go, customers are limited by technology at their home. They must have access to a computer with internet access. They will not be able to edit other user accounts or database entries. Employees are limited by the automation system right now. Book returns are still done manually using a barcode scanner, and then they're relying upon the technology that exists at the library. This technology, from system limitation perspective, exists physically at the library, so there's limited employee access from home, and the software has no function to automatically return books or process shipments, so this will still be done by employees.
This is the use case diagram for our library management system that shows all of the available actions, otherwise known as use cases, that are available in our system. This is an example of one of our use case descriptions, which is basically like an outline for the use cases. This description is for our search library inventory use case, and it provides a lot of good information like the name as well as a brief summary. It also shows if it's dependent on any other use cases. In this case, it's actually just a base use case. It shows the actors that can initiate such use case as depicted on the use case diagram. So for example, this one can be enacted by the library employee or the customer, either or being a primary actor. Use case descriptions will also show if there are any preconditions before the use case can be enacted. And then it kind of goes into a flow of events or a description of the main sequence. Now that we have looked at one of our use case description examples, we will actually go ahead and take a look at each of the activity diagrams for each of the use cases in our system. Activity diagrams are basically the visual representation of each use case that goes through the main flow or sequence of events for each use case. On the activity diagrams, you'll see rounded rectangles. These basically represent each activity node that occurs in the use case sequence of events. Then there's also diamonds that represent the decision nodes, which basically show when the sequence of events kind of forks into two different paths. And then the arrows are basically showing the flow of that sequential order of events. So this first example we have is our add book activity diagram, which is basically the flow of events for when an employee would like to add a new book into the inventory that doesn't already exist? On the flip side, the remove book activity diagram shows the sequence of events for an employee to remove a book that is currently in the inventory. On the customer side, the checkout book activity diagram shows the sequence of events for when a customer would like to borrow a book. The return book activity diagram shows the sequence of events for when a customer would like to return a book that they've borrowed. If a customer returns a book past due, the pay fee activity diagram shows the sequence of events for paying the late fee. If a new customer would like to patron the library, this sequence of events would first be followed to create a library account. Either a library employee or a customer can edit library account information by following this sequence of events. Should a library account no longer be needed, this sequence of events can be followed to delete the library account. This diagram shows the overall sequence of events to search the library inventory for a specific book. This diagram is an extension of the previous diagram by showing the sequence of events for searching for a book using the author's name. This diagram is another extension of the first search diagram that shows the sequence of events for searching by title. This last activity diagram shows the sequence of events for when the overdue book monitor sends an overdue book notification.
All right, folks, so let's talk about our next step in our software modeling evolution, and that's the eventual development of the system context class model. Now, the method we used was first developing the conceptual static model, which we will cover in the next slide in some detail. Developing that model first before diving into the context class model provides a foundation, or the beginnings of what we consider the algorithm for our broader concept, which is the system context class model. Alright, so here's our conceptual static model, and as you can see, we set out to identify our physical classes that would allow our users to interact with our software system or overall library system, and we also identified the associations between our users and these physical classes, and the multiplicity of those associations. Okay, so here's our system software context class model, and you can see that it depicts our external classes, our overall aggregate software system, and the users that will be interacting with the external classes, which will also in turn interact with the aggregate software system. Now let's delve further. We will dive into what's inside the aggregate black box in our system software context class diagram, and once we've taken a look at that and covered it, we will also talk about the different attributes associated with the flushing out of the black box and its entity classes, or classes that will remain static and unchanged. So here's our static entity class model, and it depicts all of our entity classes. We are delving into that black box that is depicted surrounding the software system. As you can see, we outline various entity classes, their associations between them, and their multiplicities. Now, these entity classes have things called attributes, and these attributes can vary not only in description, obviously, but also in type. For example, the entity class account has an attribute called account number of type integer, while the account transaction entity class has an attribute called transaction type that is of type string. It's somewhat redundant, but it's necessary to use UML notation to list out the types of attributes that each of these entity classes have, which is exactly what we've done here.
The dynamic model of our system involves an interaction diagram for each use case, a state chart for each use case in which an actor external to the system is interacting with the aggregate system, a short description of each of those state charts, a combined communications diagram, and a combined state chart. These are the interaction diagrams for the add book and remove book use cases. These show the employee submitting a user interaction, which interacts with a library inventory service to effectively update the library inventory according to what the use case intends to do. Along with the interaction diagrams, we also have state charts. As you can see, the states are shown as rounded rectangles. Arrows indicate the transition from state to state, and the text next to the arrows depict the actions or events that trigger the transition. This is the interaction diagram associated with the checkout book use case. And this is the state chart associated with the checkout book use case. The return book use case interaction diagram is almost identical to the add remove book interaction diagrams, except this situation involves the customer interacting with the library inventory service via a user interaction object. This is the state chart for the return book use case. This interaction diagram shows the sequence of communications between objects as a customer attempts to pay a fee on their account. And this is the state chart associated with the pay-fee use case. This interaction diagram depicts the sequence of communications that occurs when a user is attempting to create their own library account. Similar communications are followed when a user is attempting to edit or delete their library account as well. The create and delete library account use cases are very similar in that they both check for existence, while the edit library account use case involves a validation check upon data entry. These are the interaction diagrams or communications diagrams involved with searching the library inventory, searching it by title, or searching it by author. Just as well, the state charts for searching the library inventory by various means are very similar. And finally, we have the interaction diagram for the send overdue book notification use case. When you combine all of the communications diagrams together, you get this, one massive communications diagram depicting all actors involved in the system, all communications that occur between actors, objects, and other objects, and the information that passes between them. Finally, we have the combined state chart, which is a composite of all of the previously mentioned state charts within this system. In conclusion, we've discovered that there are several benefits to this software engineering process that we have followed. We now have detailed graphical representations of the entire system and all involved components, both hardware and software. We have made it so that future changes or updates to the system are now easier to visualize and manipulate, and we ultimately have a better understanding of the system on every level of abstraction.